Welcome everybody. Today, we will explain one of the important circuits. Power supply is one of the main element in every electronic circuit, and the right AC-DC adapter circuit should be chosen if we want our device to accept power line voltage as the main supply. There are several types of AC-DC adapter circuits: transformer-less, non-isolated, step-down transformer, and switched-mode power supply adapter. The schematic diagram of the circuits and how to implement them for our design is presented in this lesson. Transformer-less power supply adapter circuit. Warning: this circuit is not isolated from the power line voltage and causes hazardous electrical shock when get touched. There are two types of this non-isolated power supply adapter circuits: half-wave rectified and full-wave rectified circuits. The main application of this types of adapter is where a small power is needed by an isolated device. A schematic diagram of a half-wave rectified transformer-less AC-DC adapter circuit is shown in the figure. Half-wave rectified transformer-less power supply circuit. The circuit depicted in the schematic diagram shown in the figure uses only one high-voltage diode, one Zener diode, one resistor, and one capacitor. This circuit is suitable only for devices that draws very small current. Practically, this power supply circuit can be used for devices requiring not more than 10 mA. The reason behind this limitation is the use of resistant current limiter, R1, that wastes too much power when supplying higher current. There are three components values that should be selected when designing with this circuit. Half-wave rectified transformer-less adapter circuit application examples. Because of limited current specification, we might find that this circuit is only used in very limited application. Please be aware that the connected circuit should be isolated from any user's touch since the adapter is not isolated from the power line supply. Isolated blinking live indicator for power line network. Isolated live charger and supply for low power devices backed with small rechargeable coin battery. Isolated part of low power microcontroller. Isolated driving section of electronic circuitry. The formula on how to design the half-wave rectified transformer-less adapter circuit. To design this simple transformer-less AC-DC adapter circuit, you have to know the parameter of the power line input voltage, Vin, and its frequency, F, the expected, average, voltage output or the voltage at the load, VL, the acceptable voltage ripple at the output, Vrip, and the load resistance, Rload. If the resistance of the load is unknown as static resistance, then you can conduct a simple measurement. To do this, you can supply the load with a general power supply at its operating voltage, VL, then measure the load current, IL, using an ampere meter, and deduct the R load equals VL divided by IL. Full-wave rectified transformer-less power supply circuit. The circuit of full-wave rectified version shown in the figure is constructed by replacing the single diode half-wave rectifier with full-wave rectifier diodes, and replacing the R1 resistant current limiter with the reactant current limiter C1. The position of the current limiter is also moved from after the rectifier to before the rectifier. This placement should be done since the reactant component C1 only work in alternating current only, so it won't work if we place it after the rectification. Because the reactant current limiter doesn't dissipate any power, in ideal condition, the efficiency of the overall circuit be much better than the half-wave rectified version. Up to 50 mA of output current is practically feasible with this transformer-less AC-DC adapter circuit design. Full-wave rectified transformer-less adapter circuit application examples. The higher efficiency feature of this circuit make it possible for wider range of application. Please be aware that this power adapter circuit are incorporated in an isolated system where it is safe from any user's touch. It's definitely not for general purpose power supply adapter where we can plug and unplug the load from the adapter. LED lighting, this is probably the most popular application. Isolated intercom system. Isolated doorbell system. The formula on how to design the full-wave rectified transformer-less adapter circuit. In the same way with the half-wave rectified version, we have to know some parameters to design the full-wave rectified version of the transformer-less adapter circuit. Power line input, RMS. Voltage, Vin. The frequency of the power line input voltage. The output or load voltage. The acceptable, peak-to-peak, ripple of the output voltage. The load resistance.